Okay, so we'll continue on with the rest of this section and we'll complete this in one screencast. So in sections 5.2, we looked at the addition rule, talking about the sum of probabilities using the word or. In 5.3, we're talking about the multiplication rule and very distinctly use the word and. And in or are key. And that if the occurrence of event E in the probability experiment does not affect the probability of event F, two events are dependent if the occurrence of event E in a probability experiment affects the probability of event F. So let's look at examples and we'll maybe do these together. If you draw a card from a standard 52 card deck of cards and then roll a die, well, first of all, and I hear this from a lot of my students, they're not too sure of how a standard 52 card deck of cards is comprised of. You must know that for a course like this. 4 suits, 13 cards in each suit. You must know that gold starts from 2 up to 10, Jack, King, Queen, and Ace. Get familiar with a deck of cards. So, the events, draw a heart and roll an even number, are independent because the result of choosing a card has no bearing on the result of tossing that die. So that would clearly be independent. Suppose two 40-year-old women who live in the U.S. are randomly selected. The events woman 1 survives the year and woman 2 survives the year are independent. Why? Because what happens to woman 1 has really no bearing on what happened some randomly selected woman in another area. But look at letter C. Suppose two 40-year-old women live in the same apartment complex. The events woman 1 survives the year and woman 2 survives the year are dependent. Why? Well, excuse me. Because something that general, there could be a dependence on what happened in that particular complex. Now, that was not a great example the book gave, but another example, let's suppose we talk about cards. The probability of picking out, let's say, a king from a deck of cards. Well, there are 4 kings, so that would be right, 4 out of 52. But let's say I do not replace that card and then I go place another one. Well, that's dependent. Why? Because now there are only 3 kings left, and clearly that would be dependent. So replacement, not replacement, would be key in determining if it's dependent or independent. Then the multiplication rule. Notice this word "and" here that I'm highlighting. And you multiply probabilities, unlike the addition rule where we add it. So we multiply probabilities. And you could kind of go through the examples and stop when you need to. And if we have multiple independent events, all of them are independent of each other, we just keep multiplying. Now, at least probabilities. You're going to hear the word at least, at most. You must understand that language. At least. That is a minimum value. So if I say at least 3, 3 is your minimum up to whenever you need to go. At most 3. Well, that would be 0, 1, 2, and 3. You're not going, it's a max. Take all these notes down. Transfer this to your notebook. Very important rules of probability. 1 and 2 are coming from sections 5.1 and 5.2. And then what we have here is coming from our last 2 sections. Very important rules of probability. If you understand these rules, probability is much more manageable. Counting techniques. This is just incorporating everything that we've talked about into probability. Factorial. Okay. So this word is factorial, and it's defined as the following. 0 factorial is 1. It's just how many ways. 1 factorial is 1 as well. Now, what does this mean? This n factorial equal n minus 1. That just means that if I have the number 7 factorial, it would be 7, and then 6, and then 5, and then times 4, times 3, times 2, times 1. Well, how do you find all this? Yes, it's nice to know how to do it freehand, well, and that's how you do it. However, if you come to the calculator, if you go to math, and before I actually show you where to go, we have these tabs up top. If you scroll over to probability, this is where we're going to use probability in this. We're going to use NPR, NCR, factorial, and that's where we are for. So if I go back to my home screen and I wanted to know 8 factorial, which I know is, and if I want to show you, watch this, 8 times 7 times 6 times 5 times 4 times 2 times 1. Now I don't have to put the 1 as we know, but look, that seemed like a lot of work to do when I can just do 8 math, the number 4, and notice that factorial key, and we get the same number. So very important with factorial. Combination, key. You can do a lot of work with combinations and permutations. Is an arrangement without regard to order. So if I have a class of 10 students and I want to take 3 of them on a field trip, well, order does not matter. It doesn't matter if I pick that person first and then that person second, because you're still going on this trip. And you can see the formula here. You should take the notes on 1, 2, and 3, but in terms of the formula, once again, watch this. Suppose I have 10 people and I want to take 4 on a class trip. I go to math, 3, 10C4, and I got 210 ways. If I have 10 people and I want to take 4 of them on a class trip, there's 200 ways. You can maybe practice with this. Now, I don't see permutation on this slide, and I apologize. But permutation talks about an arrangement where order matters. So let's say I have 10 students, and I'm giving a test, and I want to determine how many ways can I give a prize to the top number 1 gets a prize, 1 set of prize. The second place person gets a different prize, and the third place person gets a third prize. Well, that order matters because you finishing first matters if you is different than finishing second. Well, look at the difference here. 10, math again. Now I'm going to do permutation, this P in number 2. I'm going to put 4. Look at the difference in the numbers. 10C4 was 210. But 10P4 was 5,040. So obviously with permutation, there's a lot more ways that you can arrange things when order matters. And that is the end of really the basic introduction to probability.